Good afternoon, everyone. Thank you for joining our Introduction to Diana webinar. Today, this session will take approximately 45 minutes, maybe a bit less, depending how fast I go through the presentation. It will consist of a presentation to give you an overview of the capability of our software, followed by a short demo. And the topic today of the short demo will be to show you some enhancement of our probing curve functionality, which is now quite interactive. I will show you that in the live demo. If you are familiar with our webinars, you know that during the session your microphone will remain muted. But there is a question chat box in GoToWebinar where you can type your questions, and from time to time I will try to have a look, see if there is any question relevant for the whole audience. If yes, then I will try to answer them on the fly. If not, I will collect your question and get back to you later per email. This session will be recorded, and within a few days it will be also available on our YouTube channel. So if you want to replay this session, it will be available there. So having said that, let's start, and let's go through the presentation so that I can give you an overview of the capability of our software. So Diana is a short form of displacement analyzer and is a general finite element program, which is dedicated to all type of civil engineering, geotechnical and petroleum engineering application. Our aim is to provide a range of efficient engineering solution to the daily or specific types of engineering problems, that by increasing the accuracy of the final results, our clients could optimize the cost of their project. Our core values of a company are presented on this slide and can be summarized in 3 words: trusted, impactful, and customer-centric, which is actually 4. So trusted in a sense that we develop a state-of-the-art software which provide a reliable solution for engineers. Impactful because our tools contribute to sustainability by helping engineers design projects built to last. And customer-centric, we always try to maintain a proactive mindset in collaborating with clients to solve the problem and also to hear their feedback when using our software. We have a scientific expert network, we have a global support network, and on our website you can find a library of articles, which are where you can find hundreds of papers. And there are also annual user meeting and regular webinars like this one. And we have customers all over the world. On the next 2 slides, I present a list of some of our valuable clients. We have clients in different countries, all over the world, from different organization types. Can be governmental organization, academic, university or research organization, but also from the private sectors like consultancy company or construction companies. From different sectors, oil and gas, energy, underground structures. So we appreciate their effort in trusting and using Diana for their project. So on these 2 slides, you can see some of the main companies, but this list is non-exhaustive. With respect to Diana application, let's quickly scan through the different type of application that basically where Diana can be used, going from geotechnical and tunneling to nuclear structures. So we start with geotechnical and tunneling. We have a very good integrated solution for all types of geotechnical and tunneling application. So you can use the integrated environment of Diana for any type of tunnelings and underground structures. For ground freezing, we have also the so-called 3-phase analysis. For real soil structure interaction, so if you have some sort of interaction between the underground and the surrounding soil or rock, you can model it with the concept of nonlinear interface behavior. We offer coupled groundwater flow stress analysis and many more, such as slope stability or embankment on soft soil and consolidation. Next to that, we have a very comprehensive very comprehensive solution associated to reinforced concrete and early edge behavior of the concrete cracking. That's mainly when the model of the model and the casted concrete goes through the process of hydration. For any types of concrete box, girder composite structure, we have a solution. For dam structure, it's also very important because of the process of casting, curing, hydration, and impounding. We have also a good coverage for design check, including the reinforcement based on the Eurocode, mobile loads, and cross-section design check. We have different solutions in order to give you good estimation about nonlinear response of the model without entering into the nonlinear detail parameter input and setup iteration like the sequential linear approach. Temperature and stress coupling let you analyze how the concrete goes through aging, for instance. Cooling pipe is also another powerful feature that we offer in both 2D and 3D in order to control the hydration process. Crack initiation and propagation in concrete structure, one of the powerful features in Diana. And also fire effect, how the fire could affect the durability of the structure. Among other applications, we can refer to masonry and historical constructions. In Diana, we offer different solutions at meso or macro levels. You can use Diana to model the interaction between the individual bricks and the mortar joints. For dams and dikes, Diana offers the solution. It covers all the aspects of construction. For all types of dams structure, you can consider the fluid structure interaction, dynamic effect, and also induce damage to the structure. Fire analysis is another area that, based on its importance these days, has become one of the main topics for structural checks. And again, Diana can be considered as one of the most reliable solutions. For earthquake engineering, you can use Diana for general dynamics or seismic analysis. Among advanced type of application, Diana is very well known in the field of oil and gas and nuclear structures. Based on the type of complexity, you can simulate 3D geomechanical depletion, borehole stability. For nuclear structure, you can analyze concrete containment or underground waste storage tanks, for instance. Let's now take a look at the Diana environment. Well, I would say the Diana environment, Diana IE, looks and feels very natural. Huh? It's pretty much like any Windows-based program. You have a toolbar on top with some shortcomings to the main functionality that you can find under the different sub-menu on top. You have different windows that can be positioned from left to right to bottom. I mean, these windows are really flexible and you can really move them, deactivate them as you wish. The main windows are basically the model window where you can find information about the geometry, about the mesh. You have the property window, which gives you more insight of some of the items that you find under the model geometry window and the mesh window. You have the analysis window where basically you tell Diana what kind of analysis you want to perform, the output window. So basically when your analysis has run, the results are available and show there, so you can select them and display them. And at the bottom, you find two windows, the message window, which give you a kind of log of what's going on in your model, if there is any error, warnings, or things like that, and also give you a progress of the analysis, and the Python console, because our graphical interface is fully scripted in Python. So over there, you can type your Python command or echo the Python command resulting from your clicking operation. And there is the main window, the working window. That's where the magic happens, I would say. That's where you do the modeling, the meshing, and you display the results. So everything is done in one interactive environment. And with respect to this interactive environment, we deliver, or at least we try to deliver the state-of-the-art of the solution with powerful graphical tools. So the user interface is quite intuitive with various display options and advanced selection methods. modeling functions are based on Parasolid. You have automated and robust geometry check and repairing tools if you import geometry. In terms of meshing tools, we have a powerful and automated mesh engine, both for 2D and 3D. You can generate embedded reinforcement. There is also an automatic selection of Diana elements, so you don't have to worry about that. You just define an element class. For loads and boundary condition, I would say we offer full support of load and boundary condition that can be applied at geometry level, and that's what we encourage, but with some flexibility at mesh level. It can be based on function, and it's fully compatible with Microsoft Excel. And for post-processing, we offer a complete solution to result interpretation. Next to that, we have also some material model classification, so basically separate dialog box with various input fields. Unit aspect that can be activated at the material level. For load combination, you can generate load combination for design or distinctive load combination for analysis. As I mentioned, you can generate function, whether it's a spatial, non-spatial, or a space function. And for the analysis window, we have intuitive environment to set up your analysis setup, including interactive dialog box for the phase analysis, where you can, at a glance, see the different phase and part of your model that should be activated. In terms of workflow, and this slide is very important because the story that I'm going to tell now applies to any model that you do in Diana, doesn't matter how complex it is. The workflow starts with the geometry definition. So you define all the geometry components of your model. Once you have your geometry, you assign properties. By assigning properties, I mean defining boundary condition, loads, material properties, initial field, everything. Everything is assigned on the geometry. Then you transfer this information to a finite element model. That's what you do when meshing. So you generate a mesh which creates your finite element model. Once you have done that, you set up the analysis, so you tell Diana what to do with your model. Do you want to run a linear static analysis, non-linear, what kind of output you want to have? Then you run the analysis. If everything goes fine, automatically the results of your analysis are loaded, and then you can check your results. So this is basically the workflow of Diana, starting with the geometry definition, applying all the properties to the geometry, meshing, analysis setup, run the analysis, and check the results. So it means that if you want to change something on your model, I don't know, the Young's modulus of your material or the position of reinforcement bar, you do it at the geometry level. So before you generate the mesh again, it's not transferred to your finite element model. So just be aware of that, but don't worry. Diana will raise a warning message. But everything is done at the geometry level, and until and unless you mesh, nothing is transferred to the finite element model. So you always need to mesh after modifying something in your model. To create the model or to create the geometry of your model, we have many options, from import CAD file to defining primitive or basic shapes. You can either import your geometry from a third-party CAD program or generate your model from our integrated environment. It's really up to you. Among the formats that Diana can handle are the DWG, DXF, STEP, and the IGS file. You can also import an IFC file format if you are using Revit. Furthermore, if you are dealing with terrain geometry, for instance, you can import cloud of nodes and generate Bezier surface from them. It's also a powerful feature in Diana. After importing the geometry, there is a geometry check because, I mean, you all know that from CAD to finite element program, there are always some tolerance issues that can lead to some problems. So we have many tools that help you to check the tolerance and the quality of the imported shapes. You can fix it, improve it based on certain features that we have in Diana to enhance your imported geometry. But if you want to start from a white page, you can also do that and use our basic tools that we offer in terms of modeling primitive to create and generate your model. So you can define 3D shapes such as block, cylinder, prism, sphere, but also a 2D and 1D shape, going from a polygonal sheet to the simple one, which is a point. We have also advanced modeling tool. For instance, one of them is a sweep geometry function, which allows you to sweep reference shapes along a grid wire. So, for instance, here you see we have a reference shapes, which is a cross section of a bridge girder, and we can sweep it along a curved wire. And basically, it results in this nice 3D shapes. And this can be done through action box that we have in Diana. So just in a few clicks. You can generate complex geometry with a minimum information using some smart function like the lofting operation you see from these examples. Here, from a square shape and a disk, we can generate such a complex shape. Same story here with a couple of wired. We generate this nice and complex curve shape. Same story here. So, I mean, these are smart and advanced functions that make your modeling experience much easier. Our selection window is interactive and object-oriented, so you can directly select them based on the selection filter, and you see that the selection filter offers quite some choices. And this is a nice feature, especially if you are dealing with complex models, which have a lot of geometrical entities. By selecting the right filter, you can easily pick up the item that you want to select. We are using auto-clash detection, so you don't have to worry about the nodal connectivity of the different components of your geometry interacting with each other. Diana automatically takes care of that for you, ensuring perfect continuity and connectivity. So this is Diana's job, I would say. There are other options in order to improve your geometry. For instance, you can sew two or more sheets. You can convert body and sheet. This goes in two ways. For any operation in the model with respect to the loads and boundary condition, you can use the imprint option to have the trace and track of the imposed load or boundary condition acting on your reference geometry. This is also a nice feature. Other modeling operation enable you to rotate or move face or adjust your shape. This can be done via action box or just interactively in the working environment by rotating around one of the circles representing the main rotation or pulling one of the arrows representing one of the main translation. You can select and extract and then extrude a selected face of edge, like on this example showed on this slide. You can match different parts of your model with respect to each other using the align face function when you have different objects in your working environment. And you can see that we have different alignment options. With respect to the functions, it can be assigned to the geometry to simulate the geometry thickness, for instance. Here we have a nice example of a bridge, which is a model using shell elements. And via a spatial function, we basically introduce the thickness and eccentricity of the element. This is an elegant way of using a spatial function in combination with shell element to model the thickness and eccentricity of these elements. But you can also define phreatic water level, whether in 2D or 3D. This is also a powerful feature, especially in the context of geotechnical application, when you want to deal with dewatering, for instance. Another strong feature in Diana is Python scripting and the geometry optimization with respect to the effectiveness of the model when it's subjected to such a load, and how you can reinforce and retrofit the model because of the load distribution pattern in the model. There are many powerful features that you can induce and use in conjunction with other tools that we have in Diana based on the Python scripting. So Python scripting is really a plus, but because it also allows you to interact with different programs, including Diana, because Python is a common language that is more and more used through different software. So it's really a plus, and it can also automate your work. For meshing, we have different type of mesher. These are smart processes. They recognize the generation of your geometry. So if your geometry is based on extrusion, like on my slide here, the extrusion mesh comes into the pictures and generate a nicely pattern structure mesh, as you can see. We have adaptive element size that enables you to increase the density of nodes and elements at certain corners and edges in order to have a smooth transition mesh. So this option can be activated from the set mesh property over there. And you can see the outcome of the mesh without and with the option activated using the same mesh seeding. So you see that you get a smoother mesh near the curvature. You can see also here the effect here. If you have a terrain geometry, for instance, you can see the difference with or without this adaptive element size option on or off. You can observe that with the option you have a smooth transition that you don't get if you basically turn it off. Although, I mean, the mesh seeding is basically the same. So the impact of this option is quite apparent here. You can also use grading to optimize your mesh. You have full control on the distribution of the nodes and the elements. After meshing, you can visualize the type of section that you have assigned to the model based on the different profile that we have in our library. This is done using the real dimensions, and it enables you to check the orientation and eccentricity. And I must say that this is a must because especially when you are dealing with beam and shell element, your geometry will basically look like lines and planes. So having a real 3D cross-section representation makes your model more realistic and more understandable, especially if you have to share pictures for a report. At the mesh level, you have a different way of presenting that enables you to inspect or present your model in the most suitable way, from wireframe, free face edge, feature edge. We have some solid shading display or shrunken shading display. Although there are different mesh engines which enables to generate structure and structure type of mesh sets. Here you see some example based on AutoMesh or MapMesher. Another powerful feature is incremental meshing. This is very interesting when you are dealing with complex models and you need to do some modification at the geometry level for any reasons. So thanks to this incremental meshing, you don't need to remesh the whole model. Diana automatically goes for the remeshing of the geometry parts of your model that have been subjected to the modification. So this way you can save a lot of time in terms of meshing or remeshing of your model when subjected to change. So for instance, here we have an example which we use in Cortesi from Dr. Oriol Arno. It's a building which consists of 3,460 shapes. It has 2,421 reinforcement bars, and if you mesh it from scratch, it takes roughly 10 minutes. If for any reason you need to change something in one of the single reinforcement bar and you remesh it, basically it takes 111 seconds. So it's almost a factor 6, and believe me, this is not a big model. So you can imagine that the impact of this incremental meshing is even more beneficial. The more complex and the bigger is your model. At the end, we have a series of online documentation, including our verification report, as well as our background theory. And good to mention that we have more than 100 plus tutorials available with step-by-step explanation. So if you want to exercise or practice with Diana, we have plenty of material for you. So this is it for my presentation. Let me quickly check if there are any questions. If not, then I will move to the live demo. So far, no questions. So let's move to the live demo. And for today's live demo, I'm going to use one of our tutorials that you can find on our website. It's a linear and elastic analysis of a bending plate. Nothing complicated. I'm just going to use this example or this tutorial as a base to basically play with the prop curve feature. So the model consists of a plate structure. The plate, as you can see, has two long edge and two short edge. We will use a linear property. The thickness of the plate is 160 millimeter. We will have a distributed load orthogonal to the plate, distributed. And basically, the two short edge will be supported and the rest will be free. And we will use a quadrilateral plate bending element for this model. So let me bring Diana to the picture. I will quickly show the modeling steps and then we can play with the probe curve feature. So this is Diana for the one who are not yet familiar with our program. So the first thing to do is to start a new model. You do it by clicking here, So I call it demo plate. I'm going to put that in my course folder. This is fine. So this folder basically is where the file that will be generated will be saved. And one of the first things you are asked when modeling is what kind of analysis you want to do. And by default, the structural is on. This is an important step because it will determine which functionality become available at a later stage. So now I'm going to do a structural analysis. It means that I won't be able to add, for instance, groundwater flow boundary condition, for instance. In terms of dimension, we make it 3D. Model size is basically the size of your working window. So just make sure that you have something which is big enough to accommodate your model. And the value that you enter in is basically the diagonal of the square or the diagonal of a cube in 3D. So make sure that this is big enough to accommodate your model. We are going to use hexaquad dominant measure, and we go for a linear element. I click OK. Diana is going to set up the environment for me. Take a few seconds. You can already see that Python commands are echoed based on what I've been entering. So everything is shown there, and you have also the message box that will show if there is any warning, error, or anything like that. As I mentioned in introduction, I mean, all the windows can be adjusted. You can move them. You can just put that wherever you want. So it's up to you how you prefer to work. If you want to change the unit, you have the unit box on the top right corner, on the bottom right corner, sorry. We are going to use millimeter, kilogram, Newton, second, Kelvin, radian. So we just keep that. And first, we are going to define the geometry. And to define the geometry, I'm going the polygon sheet option. And I'm going to call it plate and enter the coordinate of the different points. So the first one will be 0, 0, 0. The second one will be 0, 4, 0. Then we go to 2, 4, 0. 2, 2, 0. 4, 2, 0. And 4, 0, 0. And you see here a preview of my model. What's important, it's to notice that nothing appears under shapes. Here you see on the geometry tree, you see that there's no shapes, it's 0. So what you see here is just a preview. Until and unless you click on create, nothing is generated. So you see now I've just created the shape, and now my shape is listed here. So keep that in mind. So in terms of geometry, I mean, this is basically my geometry, nothing complicated. We can already start the property assignment, and I'm going to do that by using the assign property. So I select the shape. For the element class, I'm going to use plate bending. For the material, I'm going to define a material which I call it steel. So for the class, I'm going to use a steel, linear elastic, no extra aspect to include. And I just give the Young's modulus and my Poisson ratio. And for the geometry, I'm going to define the plate thickness, which will be 0.16 in meter. And I'm going to also align my axis. This is just to make sure that the direction of the plate element local axis is the same for every element. So when you present local results, basically you have some consistent results. And then I click on apply. If I go to material, you see that I have a material which has been created. And under element geometry, you see that I have a plate property that has been created as well. How do I know if my property have been properly assigned to my shape? One of the things you can do is just pass the mouse on the geometry set, and you see that you have some information popping up, and you see that the material steel and the element geometry plate has been assigned to your shape. Another way, when you have more elaborated geometry with multiple material assignment, is to go to geometry and color shape by material color, for instance. And then you see that the shape carry the color of the material. So this is relevant when you have complex geometry with different assignment of material. Having said that, let's continue. So now we are going to define our support. So I go to geometry, assign support. I'm going to constrain the corner. So it will be a set that I call corner on a vertex, select this point here, and I constrain the vertical direction. I click create. Then we are going to constrain the two short edge. So I say edges. Say it with the same name. So it will be edge. And I select this edge and this one. And here I select also the Y direction. I click create. And then you see the representation of our support. Last but not least, I'm going to define the load. So I can close this one. Geometry, load, assign load, sorry. I call it load, nothing really fancy. It will be on the face, and I'm going to apply a distributed force. The value will be 1000 Newton, and it will be normal, so basically acting normal to this face. But I click apply, create. So my load appear here. Yeah, I just noticed that I wanted to do that, but normal acting downward. So I update my load. I think it didn't update, did he? Let me see. It's upside down, so I'm going to do it again. Geometry, assign load, to create, assign load. That's the charm of the live demo, when you do things and you speak. Load, add, distributed force, like that, and I want it to be -1000, normal. Okay, and create apply. Something is wrong. Make sure that I do it. Create. Let me do it again, because I'm just lost in my directions. I want to apply it in the vertical direction. So geometry load. This shouldn't be that challenging. So load, distributed force here. Okay, -1000. Create. I didn't select it. Here we go, create. So let's now move to the meshing. So I go to geometry, mesh property, and here I'm going to select the shape, and I'm going to use an element size. So I select my shape, and I say that I want element of 0.25. So it will try to generate a quad element with size of 0.25 by 0.25, some square element. So I click on apply, close, and I say geometry, or I can click here, and it generates a mesh. And if you go to the mesh tree, you can find basically all the information about your mesh. So you see that my plate consists of 192 elements. You can find the material, it has been transferred to the model, the plate property, you see the element type which is used, you can see the support, and you can also see the load. So the model is complete. Let's now move to the analysis setup. And here we are not going to be that challenging. We are just going to run a linear static analysis. So I add an analysis. I call it linear analysis. And it will be a linear static analysis. I have only one load, so nothing specific to add. I can simply run the analysis. And you see here that you have some information about the analysis. You see when it started at 3:35:58 seconds, and basically it was done 1 second later. And you see that it has been creating the stiffness matrix, on the right side of the stiffness matrix, etc. So solving the problem. And if there was any problem or error, it will also show up here. So let's now look at the results. I move to the result window. I see that I have some output, which consists of displacement and element results, nodal results. In terms of nodal results, I have the displacement, I have the external forces, the reaction forces. For the element results, I have the total strain, the Cauchy total stresses, distributed forces, and moment. These are basically default output in Diana. So I didn't need to ask for specific output for this model. I mean, by default, I get a lot already. So imagine that we want to present a contour of the vertical displacement. Here we are. So we can even show a deformed shape. And then you see the deformation. So today I want to focus on one of the result feature, which is the probe curve. For instance, if you right-click on this item, you see that you have the show contour probe, but it's gray out. So if you go to the result settings, under results, you will find the probing curve settings, which are over there. And in these settings, basically, you can create a curve through your shape, and basically it will present in a kind of diagram way the outcome of this result. To create a curve, you need to click the add button and click curve, expand, and here you see that you have the point coordinate. In previous Diana version, basically you were able to enter the coordinate of your curve by typing them. So it means that you had to know them in advance, which was not always very friendly, but it was, I would say, very workable. We have introduced a snapping tool for that, which make it much more easier. So you see that when I open this, let me do it again. If I click on this box, I open it, I have these two icons here that show up. And thanks to these two icons, I will be able to select points directly on my structure, and they will be reflected in this table. So I click here, I want to add some points, and I can select some of the points that I want to add to my model. And I just go like that. And you see that these points are tabulated. And if I want to remove some points, I just click on the remove button, and then I select the point that I want to remove, for instance, the first one or the last one. Or this one, and then it automatically adjusts my curve. And then I click OK, and then I have my probing curve, and then I can say show contour probe. And here it shows a table with the variation, so you can extract that, copy to Excel if you want to make some comparison. But it can also be displayed as a diagram. So if you see here, you see the diagram, and you can play with the scale of this diagram. If I make it 10, then we can easily see basically the variation of the Z displacement along my curve. You can increase the number of points in each interval to 20, for instance, then you get a higher density because it takes the null result and does some projection as well. So that's how you can present some of the results in your structure. And you can add as many curves as you want. So I can make another one. Sorry, I wanted to expand it. Select this one. And I'm going to add some points. So for instance, from this one, I go this way, this way, this way, this way. So you see it's very handy. And you click OK, apply. And automatically you see the results. And when you go to your output and you show control probe, you can basically decide which curve you want to see from the actor curve options. So I go to the first one, I see the variation, I check the second curve, I see the variation as well. And you can easily copy and extract these results to Excel. So this is a very handy tool, which was already there in previous version, but since Diana 10.10, we have introduced this snapping tool possibility, which make it more user-friendly in a sense that as soon as you have a curve, you can easily edit it and, for instance, remove points or add points. For instance, here I just remove 2 points, I click OK, and automatically the curve is adjusted. And here you see the imprint or the, how you call it, the representation of the show baseline. So you see where is my line and the associated results to this. So this is an announcement that we have made available in 10.10. It was a request from many end users who find it a little bit cumbersome to just type the coordinate of the points. You can still do that, but from now with this interactive snapping tools, you can easily add and edit your probing curve, so it's more user friendly. So this was basically the feature or enhanced feature that I wanted to present today in this live demo. Let me see if there are any questions. Apparently not. So let's consider that everything was clear. So I'd like to thank you all for attending this Intro to Diana webinar. As I mentioned, the recorded session of this webinar will be available online by the end of this week on our YouTube channel. And I invite you to keep an eye on our website. There are more webinars coming up. We try to have at least 2 webinars per month, so just keep an eye on our website and register for the newsletter if you want to be informed about our latest event. And we have also a Reinforced Concrete course, a standard online course, coming early June. So for the one who wants to know more about Diana and about the modeling of reinforced concrete, I would say don't wait too long and go to a website and register, because the number of seats is quite large, but there is a high demand. So don't wait for too long before the course is fully booked. So thank you, and wish you to have a pleasant day or pleasant end of the day, depending where you are located. Thank you all. Bye.